Natural logarithms are good for your health. Because they're natural, right?
No, they have.
No, stop recording that.
They're rational. Just like people.
I have no idea why they're called natural logs. Okay, sorry. I just know they're good for your health. But here they are. The natural log is a logarithm base e. We write it differently than this. Okay, so it's written L N X of any whatever. So that would imply a log natural, because people other than English people came up with this first. Logarithm natural of X. Okay. So it's the same thing as saying this. Okay. So know that this is a log base E. Right? You remember let's look at the graph of it. It doesn't change a whole lot. E to the x looks something to that, right? Exponential. What do we remember that e is as a number? 2.718-ish. 71828. Okay, so these are pretty much the same statement. This is an approximation, of course, but that's the graph. What would the graph of natural log of x look like this? Yeah, it's the inverse. So this is 0, 1, we go to 1, 0. And it looks pretty much just like the rest of logarithm graphs. This goes up faster or slower than this. So just to reiterate that those are inverses again. There you go. Okay. Let's see. Okay. We can use the change of base formula here too. Yesterday I had you change it to base 10, right? We have some artists. You can also change this to a logarithm base E using the change of base formula. So there's on your calculators an ln button. This is why we use it so often. So if you can dial that up, ln 256 divided by ln 6, we're just changing it with the natural logarithm. It's not going to be a different answer or anything. It's going to end up the same. It's just a different way of doing it. 3 point? Anybody disagree? Again, the biggest part I would like you to understand, they're solving equations, so I'm gonna show you a few of them. It shouldn't take too long. Let's solve this equation. Okay, first off, always try to isolate the log. So how do we get rid of this? Yeah. Don't forget your basic algebra. I want to throw something at you. And what do you get? Negative 0.4. Next thought. 3. Next thought, 3. Again, same cube. What's the inverse of natural log? Okay, that's how your book would do it. Okay, I hate that. Your book would do this. The anti-natural log. And those cancel each other out. Is there an anti-natural log button on your calculator? No. It's stupid. Okay? I hate this. Okay, what is the inverse of natural log? It's the exponential e, correct? So my preferred method is to do this. You raise each side to the power of e. These are inverses, they cancel each other out. Well, that is actually on your calculator. How about that? What do you get? Second element, how about that? Amazing how they worked that one out, huh? This would be the same operation. You would have to do the same operation here on your calculator, except this is a lot more obvious. Okay, so, Nino like you find the things you use code, right? So you can use it, but you get it. There you go. So these are actually, they're just the same as regular logs. We're using the inverse to solve them. You can, if you wish, this is how we did common logs. That's the same statement, correct? We're writing it log base. See, if you rewrite it as an exponential, here's your base, your exponent. Okay. That's how I've shown you with common logs. The base just isn't so obvious there. Okay, so take your pick. There's 3 different ways to do it. Why not? All right. Let's try another one. So you can solve this using log naturals or log base. Other, you can graph it. So let's try it algebraically, then we'll try it graphically. So first intuition. Okay, that's a great thought. Can I do that? If this was a 9, I could make it 3 squared, correct?
Yeah.
And they would be equal and it'd be easy. But we can't do that. Okay, next thought. How do we undo exponentials? Logs. So what log base? Okay, log 3. Right. These cancel. Now, how do I deal with that side? Yeah. Remember your log properties. The exponent of a log can come out front. It's weird, I know, I really do. But it works. So I can cancel that exponential. Yeah, you can do that too. Either one works. What's log base 3/7? Decimal 1.771. Check his answer. We had some issues yesterday. Good, thank you. I'm not gonna trust you guys for a few days. Yeah, well, guilty by association. Okay, distribute, right? This linear, solving linears, we don't want to forget how to do those. And then subtract this over. Zero 0.29. Correct me if I'm wrong there, please. And then divide. Negative 7-ish. 7.5.
7.3. 7.7. Sorry.
Either I need to clean my ears out or I need to get hearing aids. Solving equations. Did I use a natural log in that? No, I didn't. You could have. With the change of base here, you could have used natural log 7 over natural log 3. But you don't have to. You got the same answer? Anybody else?
Now he doesn't have the same thing that we said. His John gave him like 16 wrong answers.
Okay, next. Let's try, oh, we're gonna do graphically, right? Do you want me to show you graphically? Yes. One person. Am I gonna burn everybody's time for one person?
Yeah.
Actually, you probably
Can I show you here?
Yeah.
Okay.
There's homework.
I'll show it to you after this. No problem. You do.
Don't do it.
Okay, there's another solving equations. It's actually easier than the one I just showed you. The big part of these, like if you hit a word problem or something, you kind of got to think it through. So I'll be done. I'll let you start working, and then I'll help some of your classmates. There it is.
Let's go.
If you're gonna be gone tomorrow, all you gotta do is flip the page past the assignment to 11.6B. And you got what we're doing. Let's call this U. I do you a favor. Bailey, are your basketball games gonna be on the radio?
Yeah.
That's cool.
So, listen to the basketball games tomorrow. And then go watch the boys' game. 101.1. Okay, son, you can look it up on the internet as well. They have internet listings.
You'll find something.